In this video, we're going to take a look at how to use the quadratic formula to solve a quadratic equation. And so far, we've had a couple of different ways we've talked about for solving quadratic equations. First off, long time ago, probably at the beginning of this semester, we used the zero product property to solve any equation that was degree larger than 1. So we used the zero product property. And you would remember that by looking, it kind of looked like this, where we factored the equation, we set the equation equal to 0, we factored it, and then we set each of its factors equal to 0 and solved. And then more recently, just a couple days ago, we looked at solving a quadratic equation by using the square root property. And I had said if you can set up the equation such that you have a perfect square that equals a number, then you can use the square root property by taking the square root of both sides. And then lastly, we talked about solving a quadratic equation by the process of completing the square. And that was your homework for the last 2 days, where you had something like x squared plus 4x minus 7 equals 0, and you had to move the constant to the other side, and you took this number, multiplied it by a half, found the number to add to both sides to make it a perfect square when you factored. Well, today we're learning yet another way of solving a quadratic equation, and it is the last method that we're going to learn to solve quadratic equations. So if your quadratic equation is written in the standard form, and this is the standard form for all equations, where all the terms are moved to one side and your equation equals 0. So if it's written in the standard form, ax squared plus bx plus c equals 0, then the solutions to the equations are this. You can find the coefficients in front of the x squared term, the x term, and the number that's all by itself, and you can plug them into this formula where x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And you should memorize that because you'll be using that a lot for the rest of this year and your junior year. So let's work through some of the examples on how to use the quadratic formula. All right, so the very first thing I want to do is I want to highlight my a, b, and c values. I'm going to say a equals, b equals, and c equals. All right, is my equation set up in the right form? Do I have ax squared plus bx plus c equals 0? Yes, I do. All my terms are on one side. And you'll notice, remember, when we have a missing term, like we have a missing coefficient, its value is 1. So here I have a value for a of 1. B looks like it's a positive 9, and C looks like it is 18. I don't know why I wrote 0 there. Is 18. So the formula that was written above was negative b plus or minus the square root of b squared minus 4ac all over 2a. So I'm going to go ahead and just substitute those values in. Make sure I put them in parentheses. 9 squared minus 4 times 1 times 18 all over 2 times 1. So let's go ahead and evaluate that. Negative times 9 is negative 9, plus or minus 9 squared is 81. 4 times 1 is 4 times 18 is 72, so that's a minus 72 all over 2. So what is 81 minus 72? Well, that turns out to be 9 over 2. And I know that 9 factors into 3 times 3. I have a nice group of 2. And I have negative 9 plus or minus 3 over 2. Well, I know that I can add and subtract 3 from 9, so I'm going to set up 2 solutions to solve, the positive solution and then the negative solution. All right, so I know that is going to be negative 6 over 2, which is negative 3. And then I know that's going to be negative 12 over 2, which is negative 6. So I have two solutions, x equals negative 3 or negative 6. Okay, let's move on to our next example. So we're going to do the same thing here. We're going to find our values of a, b, and c. But first we're going to ask ourselves, are we in the correct form? Are we in ax squared plus bx plus c equals 0 form? And it looks like we are. Our equation equals 0. You can see that our a value again is going to be 1. Looks like our b value is 16 and our c value is 64. So I know that my solutions will be b squared minus 4ac all over 2a. And when I substitute those values in, I get negative times 16 plus the square root of 16 squared minus 4 times 1 times 64 all over 2 times 1. And when we evaluate that, we get a negative 16 plus or minus the square root. Well, 16 squared is one of those perfect squares that we memorized earlier this year. Minus, what's 4 times 1 times 64? Well, it's also 256. And then 2 times 1 is 2. Well, I know that 256 minus 256 is 0. And I know that the square root of 0 is 0. Plus or minus 0. If we add or subtract 0, that negative 16 won't change. So it looks like we only have one answer here, which is negative 8. So x equals negative 8. All right, our next example. Okay, we're going to start off by finding a, b, and c. Are we in the correct form? Ax squared plus bx plus c equals 0. It looks like we are. Again, a is going to be 1, b here is 10, and c is also 10. So when we use our formula, and you should practice this by writing it with each problem so that it helps you memorize what it is. When we substitute in, we're going to use parentheses, plus or minus the square root of 10 squared minus 4 times 1 times 10 all over 2 times 1. And when we evaluate that, we get a negative 10 plus or minus 10 squared is 100, and 4 times 1 times 10 is 40. All over 2 times 1 is 2. So I'm going to get, let's see, 100 minus 40 is 60. And does 60 reduce? I don't know. So I'm going to go ahead and factor 60 into its prime factors. And I know that 60 is 2 times 30. 30 is 2 times 15. And 15 is 3 times 5. So it does look like it reduces. We're going to pull out a nice group of 2's here. And we get negative 10 plus or minus 2 square root of 15 all over 2. And I would like you to notice that all the numbers, negative 10, 2, and 2 on the bottom, all of these numbers, we're not talking about any numbers under the radical, but all of these numbers have a factor of 2. So I'm going to take out a 2 from all of these numbers, and I get a negative 5 plus or minus 1 radical 15 over 1. And I don't really need to divide by 1. So now I can just say x is negative 5 plus or minus the square root of 15. All right, our next example. We're going to start off again by finding our values of a, b, and c. And are we in the correct form? ax squared plus bx plus c equals 0. Yep, all of our terms are on one side. Again, our a value is 1, our b value is 14, and our c value is 65. And yes, a, b, and or c can be negative as well if you were thinking that. We're going to go ahead and plug those into our formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have negative 14, negative times 14, plus or minus the square root of 14 squared minus 4 times 1 times 65, all over 2 times 1. So now we have a negative 14 plus or minus the square root of 14 squared is 196, and then 4 times 65 is 260. So it looks like we're going to have a negative under our radical, which means we are going to have a complex solution because we'll have a real part and an imaginary part. So what is that going to be? That's going to be 64 minus 64 over 2. And I know when I factor 64, I get a negative 1 times, and I know 64 is 8 times 8, and I have my nice group of 2 8s. And we know that the square root of negative 1 equals I. Okay, so I'm going to cross that off. So our final solution, or our solution right now, is negative 14 plus or minus, we're taking an 8 out, and the square root of negative 1 turns into an I over 2. So again, you should check all of these numbers. They are all divisible by 2. So I'm going to divide all of these numbers by 2. And I get negative 7 plus or minus 4i over 1. And I don't need that 1, so I'm going to erase it. And so my final answer is negative 7 plus or minus 4i. All right, so we have 4 more examples, but I think I'm going to start another video. So for right now, why don't you work on the first 4 problems on your worksheet and follow those examples because they are really good examples of how to use the quadratic formula.